All right, so section 8.3. So one sample interval for the mean. So now in this section, we are going to be dealing with quantitative data. So suppose you want to estimate the mean height of all Americans, or you want to estimate the mean salary of all college graduates. Okay, in these cases, we need to find a confidence interval for the population mean because we've got quantitative data. So again, we're still going to be using the same acronym, PANIC, for our 5 steps. So again, in doing inferences, we first need to state what it is, the population parameter that we are interested in doing a test about or trying to compute an interval for. So in this case, since we have quantitative data, that parameter will be mu. So this is going to be the mean measurement of all objects. Okay. That's the value that we'll be after, and we can get some information about that from the random variable x bar, which is going to be the mean measurement of n randomly selected objects. Again, every inferential procedure has its list of assumptions to check, and again, these are on your cheat sheet, so you don't need to memorize them. Again, our first one is always going to be that we're just going to assume a random sample of size n was taken so that there's no bias in the sample. But now for quantitative data, our checks are different than they are for qualitative data. So in this case, we either need to know that the population is normally distributed, so they either tell us that or they give us data that we can then use the methods from 6.4 where we look at a modified box plot and a normal probability plot, or they give us a sample size of at least 30 and we know that there can't be any outliers in the data set for this intro course. Again, we're just not going to learn how to deal with outliers in this intro level course. So if you are given data, which many times in this section you will be, you can then run the test from 6.4. So you can make a modified box plot, make sure it doesn't have any outliers to it, and then make a normal probability plot to make sure that it's roughly linear. Should also check the histogram to make sure it's kind of roughly bell-shaped, but again, that's really hard to do for small data sets, which is why the normal probability plot was created in the first place, was to, again, be able to assess normality better with small data sets. And then the last one is that the population standard deviation sigma is unknown, which again, keep in mind that is typically the case, that we would not know the population standard deviation. So in this case, if those conditions are met, we will be able to use the t-interval procedure. All right, so then the fourth step here, we're going to find the confidence interval. So we're going to start with the point estimate, which for quantitative data, that's going to be x. When we don't know mu, our best guess for the value of mu is going to be the value of x bar from our sample. Now that value is either given to you or you can get it from one variable stats. It's also, we're going to see this is also on the t-interval output screen. So to get the confidence interval from mu, again, we're going to go into that stat menu. We're going to arrow over to tests, and in there we're going to choose t-interval from that list of choices there. Now we've got a couple different options for quantitative data. So if they actually give you a list of data, you're going to enter that list of data first, and then you would highlight data and you would tell it what list you put that data into. Or if you're just given summary statistics, if they just give you x bar, s, and n, then you would highlight stats and just give it those 3 pieces of information. Either way, then we give it the confidence level and then we hit calculate. And then the output screen, no matter which input screen we start with here, the output screen then gives us an interval. So the first one is our interval estimate for mu. And then it gives us the value of x bar, which is our point estimate for mu. And then again, it gives us some of our other summary stat information here with the value of s and n as well from the sample data. And again, StatCrunch also in the stat menu under t-stats one sample. And again, you have the option of choosing with data or with summary, just like on the calculator. So again, if you have data, you would select the column where you put that data and the confidence level. Okay, otherwise, you would input the summary stats, the sample mean, sample standard deviation, sample size, and the confidence level. And again, on the output screen, you need to look under the columns lower limit and upper limit to get those 2 endpoints. And finally, our last step, so panic, the last letter is C, and that's a conclusion in context. So again, we're going to say we're 90% confident in this case that the mean measurement of all objects is between the lower endpoint and whatever that upper endpoint come out to be.